morning, everyone. It's my first time to come to the QP conference, so I'm still nervous now. And first I want to thank a lot of people, especially the Professor Bai. He fixed my USB file yesterday, so I can go through very smoothly.
Bai is me. Okay. It's just my name is surname in Chinese.
And I want to thank you, Professor Louis Chen and Professor Stan's encouragement and Professor Akagi. They gave me a lot of encouragement so I can stand here very strongly. Thank you very much. And today my topic is nonlinear functional of space noise. And I want to also thanks visiting Nagoya University 2 years, give me a good research environment. And I also want to thank Professor YJ Lee and Professor Shi Xinhong, who then give me a lot of encouragement to do the research. And also I want to thank the conference give me the chance to deliver my speech. This is some summary of my paper, but if the time is permitted, we will go back to see it. Yes. And my research is focused on the Poisson process P and the P because a lot of people do if the P dot T is focused on PP. But I'm focused on the space lambda intensity. So I do the P prime lambda to investigate the noise. So we call it a new noise or a space noise. So my speech will focus on the P prime lambda. And first we will give some introduction. Actually my research is promoted by the Levy's paper, Paul Levy's paper. And in our common known three noise is white noise and Poisson noise. But they are focused on the time parameter. And the third one is what I research is P prime lambda. So we fix the T and to investigate the lambda when lambda is greater than 0. And because we know a very special thing is we don't have the L2 known topology to investigate the P prime lambda. So we only can use the tool is the characteristic functional. So we focus on first we will introduce some property of the secrecy. And next section, we will want to renormalize, like the professor Hida, how to construction the white noise. And we will put the P prime lambda, the space noise in the R1-1 space. Why we call it R? Because in the German, R and W means the space. So we use the capital R to mean the space, like the Hilbert space. So we can introduce the R1-1 as a generalized linear functional, where P prime lambda lives in. And also we want to investigate some P prime lambda's polynomial, but this part is still on work, not yet finished. So I still to do hard work now. And sorry. So the linear functionals of P prime lambda is mean the form like the integral, but actually we analogous to the polynomial summation 10. And we try to use it to investigate. And this F is on the L1 space. First, we have the First, we have the theory. The theory is if x and y are independent, then the kernel function f and g, the product will be zero almost everywhere. So it's just briefly proof. If we can separate the characteristic function, so we can know the proof can be complete. But we know from 0 to infinity is a little hard to do the scale. So we separate it to 4 parts to do the proof. And because the A, B, C part is very easy to check, so we just focus on the D part. And we differentiate, so we can get the F and G is equal to 0. And their product also equal to 0. And next, our corollary is if the P1 and P2, and P1, P2 is also independent, then the functional of the P1 and functional of P2 also independent too. But in the future, we want to be a Fn function, but now we still work on it. It may be more difficult to research. And the lemma is